Hello everyone, and in this video we're going to look at how to identify conjugate pairs in either an acid or a base reactions, which is known as a neutralization reaction. Now in this part, let's just talk a little bit about what acids are. There are a couple of definitions for acid, but what you need to understand is for you or for a species to be an acid, it must have first an H plus, and secondly this hydrogen ion, or is called a proton, will be able to react with water when water is floating around in a solution. And what happens is water picks up this proton and then forms a product which is called an hydronium ion in water. Now on the other side, when it comes to a base, we must have a species that contains a hydroxide ion, which is represented as OH minus. And what happens is when water is actually floating around in that particular solution, what we notice is that this hydroxide picks up a hydrogen atom in water, and what results in this is the formation of a hydroxide right there, and then another water is released in the process. So since you are able to differentiate between what acid species is and a base species is, we're going to dive into the first question, which is when hydrogen chloride actually reacts with sodium hydroxide at equilibrium, salt or an ionic compound is formed and water. Now looking at this by inspection, first of all what you want to think about is what are the individual species in the reactant. What you notice in the reactant is that we have this particular first one to consist of a hydrogen ion and a chloride. This actually reveals that this presence of a proton in the left side is actually an acid, so we identify this to be an acid species. And then looking at this other reactant here, we notice that if you split this into two, we have sodium plus and hydroxide in solution. The presence of this hydroxide shows that this particular species here is a base. Now we need to find the pair that actually consists of the matching of the acid and base at the product end. Now looking at the product side, what we notice is that we have this particular ionic compound. So for the ionic compound product, we usually ignore the positive aspect of the product, so we just scrap that out in here, and what we focus is this particular chloride. And what you notice is that since this chloride comes from the acid, which is on the left side right here, we actually consider chloride to be the conjugate base, while on this other side, since we have water being formed, we notice that water is a composition of the hydrogen ion and that of the hydroxide ion. And what happens is that the hydroxide actually picks up a proton to form water, so there is a transformation of hydroxide as a base becoming a conjugate acid, which is in this case water. So since you're able to understand pairing the acid right here to the conjugate base and the base right here to the conjugate acid, we're going to dive into another example here. First, I'll give you guys a few minutes to work on it independently, and then we're going to dive into the solution now. 1, 2, 3, let's go. So looking at this here, we have this particular copper called hydrogen cyanide, and hydrogen cyanide is going to be reacting with an arsenide, and this arsenide actually is noticed to have a negative charge, but what you notice is that the product formed is cyanide negative charge plus ammonia. So what you notice here on the left side, if you split this, we actually get H plus and Cn minus. In solution, this H plus presence tells us that this is the acid, and then this other one right here is known to be a base by default. You can have two acids, except one is actually a weaker acid compared to the other, but for the purpose of this example, we're going to determine first which one is the acid, and the other component of this particular reactant is considered by default to be the base. So at equilibrium, our product, what we notice now is that, hey, we have cyanide. The cyanide here comes from the acid, therefore this is actually called the conjugate base of the acid. And while this one over here, what happens is that arsenide picks up a proton right here and then forms ammonia, and this ammonia here is considered to be a conjugate acid. So what you notice is that when you have the left side to be considered to be the acid, the conjugate base looks like it is an acid, but just think about the product as the opposite of the function of the pair in the left side of that particular reaction. All the same, thanks for following me through this. Hope you're able to get a feel on how to investigate into what acids and base are, comparing that to the conjugate base and conjugate acid respectively, and the characteristics involved. All the same, stay smart and believe in yourselves.